right, hello everyone. So I need to talk through this mic in order for the live translation to work. So if I happen to drift away too much at all, just raise your hand or something, and I'll take that as a reminder to hold it closer to my mouth. But yes, thank you everyone for coming today, this afternoon, to listen to our talk about owning your data, leveraging OpenStack and Sunbeam to deploy a sovereign AI cloud. Okay, let's see here. All right, there we go. So yeah, one thing that I like to do before each presentation is just kind of introduce the speakers that we have here. So even though it's just me standing up here today, this is actually a collaborative talk that was put together by two engineers within the OpenStack organization at Canonical. So me up here, my name is Jadon Nucciarone, and I'm pretty, involved with a lot of stuff around the Ubuntu community. So primarily I work as a high-performance computing engineer at Canonical. Outside of that, I also volunteer a lot throughout the community as an Ubuntu member. So for example, I help organize the yearly Ubuntu Summit that we have. I also like to help organize regional events in the Americas. I also like to make snaps. I'm a part of the Snap Crafters, and also we have a community team as a part of Ubuntu called Ubuntu High Performance Computing, where we work together with lots of folks around the industry to kind of promote using Ubuntu as kind of the base distribution for high performance computing workloads. And so my very excellent co-speaker here, unfortunately he wasn't able to make it to South Korea, but he was very much involved with working to put together this talk. So I wanted to kind of give you a chance to know who is doing the magic behind the scenes to help with that, who is Jadon. He has a extensive career experience working with OpenStack, so I decided to put OpenStack expert up there. He's also very into using Terraform, doing a lot of work with that, and helping develop the Juju Terraform provider. He also does a lot of work with Juju, and yeah, he's also I would call a Sunbeam power user. He likes to do interesting things with Sunbeam. So now that we've gotten through introductions here, one thing to kind of look at is the topic of this talk, which is the sovereign AI cloud. And so obviously when you first read this here, you're kind of like, well, what does that mean? And so maybe if you're looking at it from the marketing sense, it's a great buzzword. Obviously with ChatGPT coming out, really revolutionizing the industry there, a lot of folks are trying to kind of capitalize on that market and kind of sell AI products, and so you'll see a lot of interesting, marketing language. And so this one, which is a common one, which is Sovereign AI Cloud. So one thing you might say is like, well, it sounds cool, but why exactly would I want it? And so, obviously to say there, it's not all smoke and mirrors. So it's not just, kind of a cash grab to actually get folks, to give you your money, but instead actually, creating real world value. So one thing that I think is really important to highlight is kind of the renaissance of private cloud per se. So I know maybe say a few years ago, everybody was like, oh, private cloud is going away. Obviously, a lot of folks were actually going ahead and jumping on public cloud. But one thing that really helped with a lot of renewed focus on actually working with AI was that, hey, public cloud is actually quite expensive. So if you don't actually have a great plan or architecture for when you're setting up your clouds, you quickly find out that the credit card bill per se gets very expensive. And so one thing that I wanted to highlight on stage left here is kind of this diagram that we have up on the screen. It was a recent survey done amongst a bunch of CIOs, and kind of found that a lot of organizations are like, oh dang, our public cloud is super expensive and we're going broke. We want to go back to actually using private on-premises cloud. And kind of interesting to see, where everybody was shifting away, and now they're kind of realizing, hey, maybe it's actually better to come back and reinvest in technologies like OpenStack and Kubernetes for local use. And so then another benefit here, kind of then focusing on, say, the sovereign part of the cloud, is that kind of with AI, there start becoming a lot of questions of kind of like regulation and how data is being used. So obviously, for example, if you're coming from Europe, they have, say, GDPR, very strict data privacy laws. And one thing is that, if you want to actually train AI to do things, you need to be able to actually prove that you can, responsibly manage that data. There's also kind of, national security aspects as well. So you want to kind of, say, focus on, hey, we don't want to put our cloud in some random place that we don't necessarily have control over, and we want to have kind of our own local data center. And so, kind of up here, what these examples show is how folks are really looking at, sovereign cloud to build the future of their cloud infrastructure, and instead of focusing on like having this massively distributed system with crazy amounts of availability zones, instead what they're focusing on is how can we make sure that we have our environment tightly controlled. And so now one thing about maybe necessarily being like, hey, I want my own sovereign AI cloud is common, say, misconception about cost of actually putting it together. So, for example, up top here, when a lot of folks are scoping out a new system that they're building, they obviously very much quickly look at how quickly, they can get a system deployed and how, fast they can actually start delivering products to their customers. And so, obviously they say, well, we get it done so quickly, so obviously it's better. And then, say maybe you look at the usage rates, they put it very small numbers so it doesn't look like a lot. And this idea is that, if you actually opt for private cloud instead, so, kind of purchasing your own hardware, building your own system, and setting up and deploying it, requires a huge amount of, investment and time, people, money, all that good stuff. And so another way that I like to put it is, do folks look at the concept of potentially building your own private cloud instead of using cloud as taking a bunch of money and lighting it on fire? So that's something that I've always seen where I'm like, hey, private cloud is pretty cool. I like the idea of being able to kind of control my setup, be able to control my costs. But everybody's kind of like, oh man, with the hardware and all the people I got to hire to actually go ahead and deploy it, there becomes this issue of like, I'm gonna go broke. But that's not necessarily the case. So you might be looking at this thunderstorm here, and if you're given the task of actually setting up a private cloud and moving away from, say, public cloud, it might be a little dark and stormy. You don't know necessarily where to go, you don't know what technology to use, you don't know what's going to be best for you. So your mind will be this cloud of anxiety and frustration. But what if it didn't have to be this way? What if, instead of the dark, stormy clouds, the skies could open up and you have the Sunbeam to help show you how it's all done? Well, conveniently enough, there is such a project for OpenStack called Sunbeam. And so, for example, Sunbeam is a really great tool, something that Canonical has been working over for the past couple years now, if I'm correct, And so, the idea behind OpenStack is that Canonical has a lot of practice and experience with actually managing and deploying OpenStack for large berth of customers. And so originally that distribution was called Charmed OpenStack, which relied on the usage of charms and Juju to actually go ahead and deploy your services. And then we have the Ubuntu Cloud Archive, which is very focused on actually delivering the different packages for the distribution. And so Sunbeam is kind of a new project, taking the lessons learned over the past 10 years and effectively saying, like, how can we make a better way of distributing OpenStack to customers and also just, general user community. And so one thing that kind of makes, say, Sunbeam unique compared to Charmed OpenStack is that it uses Kubernetes under the hood to actually kind of provide a lot of the high availability and orchestration for the various services that make up your OpenStack cloud, which the benefit of that is it makes it quite portable and easy to get pretty much wherever you need it. And so actually now, you can look at a lot of the benefits here. So for example, Sunbeam, I like to say it's quite simple. Maybe that's just me as an engineer, knows how Sunbeam works. I know people who work on Sunbeam. And so obviously see how everything goes together there, but I think it's only like 6 or 8 commands to actually go ahead and deploy your own OpenStack cloud. Another thing is that it's very developer friendly. So one common issue I think you'll find with OpenStack is there's quite a learning curve if you do kind of more traditional deployment. I've heard some folks say that it's taken them about 2 months to actually get their own production OpenStack working. Sunbeam is actually pretty great for getting you up running quickly. And so that's why it's more developer friendly. So if you're writing applications or writing applications that need to run on the cloud, it's a lot easier to spin up your own actual environment to start doing that work, but also then have something that translates up to actually your enterprise workloads. Another great thing about Sunbeam is that it's collaborative, so you can expose various APIs to actually spin up their own environments, so you all develop off of the same cloud. And the last thing is that Sunbeam is actually pretty lightweight, so it has minimal overhead and it has simplified lifecycle management, thanks to Juju. So the idea is that you don't have to spend as much time managing your OpenStack cloud and can actually focus on getting the work that you need to get done. But there's always kind of one problem, where a tool like Sunbeam, you can look at that and say it's only one piece of the puzzle. And so one thing that I always find fun, especially with my background in HPC, is that opinionated infrastructure is very straightforward. So it's like, here, take a script, go deploy your cloud. But often, sometimes it can be a paper tiger. Once you actually find an actual use case that you want to work with, you can find that, hey, these opinions that I formed broke down pretty quickly. But actually, Sunbeam can be pretty useful there. So you can kind of look at it and say, how can Sunbeam be used to actually, as a piece of the puzzle, build a private AI cloud? So one thing I like to kind of think here is a bit of a sandwich. I don't know if maybe I'm hungry or something, or just thinking of home. I'm currently about on a 12-hour time difference, but back in my home city of Pittsburgh, which is in western or eastern United States, Great Lakes region, for anyone that doesn't know where that is, we have a popular restaurant chain called Kubernetes, and their whole thing is kind of making these overloaded sandwiches that are for people that are working hard during the day. Maybe not necessarily software engineers, unless maybe you're standing at a desk or something, or you're really typing a lot and somehow burn lots of calories there. But the idea is that you can kind of almost look at your sovereign AI cloud as like a sandwich. So you have all these interesting technologies that you can work with that are kind of the ingredients that come together to compose something that's useful for you. And so on the topic of food, instead what we have here is the sovereign AI cloud sandwich. So maybe it doesn't look as appetizing, but it definitely is probably much more of a revenue driver than, say, eating a sandwich. And so, obviously, maybe more of a open-faced sandwich per se, you'll kind of look at it and see as, hey, there's a lot of different, pieces that are available here, a lot of different things at play. So the first piece that I want to look at is kind of the base layer of your sovereign AI cloud, which is MAAS, which is an acronym for Metal as a Service. And so, kind of looking at this picture here, effectively what MAAS allows you to do is take advantage of your bare metal hardware resources in different availability zones. And the idea is that you can kind of take multiple different operating systems, so say like Red Hat Enterprise Linux or Ubuntu, and deploy it to a wide variety of different, hardware providers. So for example, like Cisco, Dell, IBM, whatever they have. And so the idea is that what MAAS is able to provide is a way for you to effectively talk to your different machines that you have available in your availability zones and actually set up images on there. And so obviously that's pretty great that you're able to actually go ahead and talk to your resources, but you might be wondering, okay, that's great. I have a way of talking to all these cold, lifeless machines in my data center, but how do I actually orchestrate and set up applications on them? And so now, this is where the fun part comes in, which is Juju. And so Juju, if you're not familiar with it, is an open source orchestrator that is developed by Canonical. One thing that I commonly find when I actually go ahead and talk about Juju is that a lot of folks are quite like, well, that sounds cool. Is it just, say Ansible with extra steps? And I say no. And so one thing that I always like to put up when I talk about Juju and kind of the role it plays is how it kind of compares to other popular tools that are out there in the ecosystem. So for example, the one that almost everyone I think uses, which is Ansible, and then Terraform. And if you kind of look towards more at the top of the screen there, text might be a little small for the folks in the back, but the idea is that it kind of shows what Juju is able to cover. So for example, it can do everything from almost everything from infrastructure provisioning to app installation and configuration. So, say setting up your services and then actually configuring them and handling how they talk to each other. And then also then doing lifecycle management as well. So for example, say you want to upgrade your service after a certain point. You want to actually monitor or observe how that service is doing. Or you just want to do typical stuff like backup and discovery. And so you might look at all of this, and as I like to say, it's magic, which I think Juju in South African language actually translates to magic. But really, how it all works is it uses charms. So effectively, Juju is the orchestrator, and then what Juju actually deploys and manages are these kind of units, or say subunits, called charms. And so if you look in the center of the screen here, effectively what you start with is, say, an application. And then those various shapes in the center kind of represent the different software bits that you're actually working with there. And so the idea is that you can almost say, like, oh, this application kind of provides, like, say, maybe, hey, like my scheduler or something for training your AI models. And then the things that are in aubergine, I think that's the way to pronounce the color, if you loop around, it has different kind of bits of logic for how to actually work with the application. So say if you look at stage right, it could have code for how to actually set up your observability stack. So if you want to see how the overall health of your cloud is going, you use that. It can do patching, so it can apply various updates. Also do identity management, so like say, hey, this user that's running this workload is actually who they say they are. You can also set up logging and auditing as well, so if you want to collect logs from how your application's doing. And it can also handle other things such as like secrets management. So if you have sensitive information that your services need to exchange back and forth, you don't have the risk of exposing them. And then also, yeah, no, that's pretty much it. The idea is that with charms, you can kind of encode all the necessary logic, and then Juju can handle actually firing those different events and processing them when you deploy your applications. And so now, you might look at it and say, okay, well, that's cool. How do I actually work with Juju and those charms to actually deploy my applications? Well, this is where Terraform actually comes into play here. So using various like Terraform plans and bundles, you can basically define how your charms shape up in your infrastructure. So you'll see all the various like orange boxes here. And so effectively what those are just like the individual charms around the applications that you might be working with. So for example, you could say you build a HPC cloud for training AI models, or you could be building something that uses Kubernetes. Those various services that would build those clouds would be in the charms. And then the dotted lines that you see are kind of how they're able to talk to each other. And so in Juju terminology, those are called integrations. I think the legacy is relations, but the idea is that a lot of the back and forth communication is handled automatically for you, so you don't have to worry about doing manual configuration. And so now that you've kind of seen, as part of the sandwich, all the fun little pieces there, so you have, say, Moz for actually, going out and getting your resources. You have Sunbeam for deploying your OpenStack. And then you have Juju for actually orchestrating those applications that you put on top of your OpenStack. And then the different hypervisor. You have, say, two different choices here. Working with Sunbeam is you can either, say, deploy a machine-based cloud, so something that works with virtual machines, or you have something that works with, say, Kubernetes, so like K-based. And so for the first example, working with, say, a end-user model, that's like an application or cloud that you could deploy for training your AI models. This one, which is machine-based, an example application is called Charmed HPC. And so Charmed HPC is an application that I work on at Canonical. It's currently, I'd like to say pre-alpha. We're kind of stabilizing and making various features more robust. But the idea is that using Juju, you're actually able to deploy a full HPC cluster, so you get the various different services. So if you look in the center here, you'll have, say, the job scheduler. If you're familiar with HPC lingo, that'll be called, say, Slurm, which is a simple Linux utility resource manager. You'll have other bits there providing the storage bits, such as like Ceph, and then you'll have various components for actually doing the identity and access management. So then, obviously, you have your machine-based applications that you can deploy for your AI cloud. So you have Charmed HPC, but you can also actually deploy, say, Kubernetes-based applications. And so for this one, typically what will happen is that you'll notice in the center there that Sunbeam uses Kubernetes under the hood for actually deploying it. Typically, you don't want to wire into that because that can actually mess up Sunbeam, so you don't want to do that. So typically what you'll do is actually deploy Kubernetes on top of that. And at that point, once you have that Kubernetes, you can start working with different K-based applications. And so a popular one that you can actually use to, say, build your software and AI cloud is Charmed Kubeflow, which is a very neat application for basically setting up and training and publishing ML and AI models. So here, various Charmed components. Kubeflow itself is quite a architecturally complex application, many different services at play there. So it has like Kubeflow pipelines, which is effectively a way of training AI models. It has like MPI operator, which is basically a protocol for spreading data across various nodes, and then different add-ons as well. And so obviously, one thing is that you could say, it's like, wow, that sounds complicated. So obviously you have multiple layers of abstraction there. So you're working with, say, you already have Moz, so you have that part there. You have to set up your servers. You have Sunbeam to actually set up OpenStack, and then you have Juju on top of that to orchestrate your applications, and then the extra layers of complexity to deploy the applications that users will actually interact with, like an HPC cluster or, say, a Kubeflow cloud. And so you might be wondering, can we actually put together our AI sandwich? So hopefully the video comes up here. All right, great. So what you'll kind of notice here is the demo script that's actually running. So one thing that you'll first see here is, I believe it is setting up Moz. So it'll go ahead there. You'll kind of notice it rocketing along there. I'm going to pull up a little front here so I can kind of see how things are going. So yes. So now that it has Moz set up, it's setting up an LXD VM. Going to wait a few seconds for that. And now it's waiting for the LXD VM to reach ready status. It takes a bit. And so now that it's ready, I'm going to go ahead and wait for another LXD VM to be deployed. It also takes a bit. So this video, it's sped up about 10 times. It takes a full 30 minutes for the cloud to actually go ahead and deploy itself. So we sped it up so that we can actually get it done in the presentation. Otherwise, it would just be sitting waiting for LXD VMs to start up. But you'll see here, going ahead. It's quite interesting. You get to see a lot of text, but there's a lot of magic happening in the background. And so now it's setting up microcates. And here, now it's actually setting up Sunbeam. So it's deploying the different services to Kubernetes. So the text is a little small, but it'll be okay. But the idea is that as you're kind of waiting here, what's happening is Sunbeam is actually going ahead and deploying the core services for OpenStack to that microcates instance that it brought in. And then once that's set up, we can then actually use Juju to start working with the OpenStack that we've set up. And so kind of what's happening in that demo script is that first we set up Moz, and then we made Moz aware of different LXD virtual machines that we worked with. And then after we kind of set up and provision those virtual machines that we need to work with, we actually go ahead and deploy Sunbeam. So it takes a little bit for just all the services to come online, because obviously OpenStack is quite a complex application. But once those all start up, we'll actually progress to then the next stage of setting up the Sovereign AI Cloud. So we're getting there. 27 out of 30. Come on, you can do it. All right, 28 out of 30. 29 out of 30. And there we go. Now it's setting up my SQL and the OpenStack hypervisor. And now it's adding the OpenStack hypervisor unit. There you go. And now what it's working with here is data science stack. So effectively what that is a more lightweight version of Kubeflow, something that's worked on by our AI ML team at Canonical. It's an open source project to basically make it easy for, say, AI scientists or AI ML developers to actually get an environment to start working with. And yeah, that's pretty much it. So the data science stack gets fully deployed, and at that point, you'll actually be able to start working with your AI cloud there. And so obviously, if you thought a bunch of text scrolling was interesting and to see kind of all the magic that's happening there, if you're actually interested in trying it out yourself, we have the demo script published to GitHub. So if you actually scan this and then go to that repository, it'll take you to some bash scripts that will actually help you be able to set up Moz, get LXD working, have Sunbeam deployed, and then actually set up your AI cloud on top of OpenStack. I'll give everyone a hot second to go ahead and scan that. Is it working, Guillaume?
It's not working.
It's not working? Oh no!
It only shows QR code monkey.
What? It's going there? All right. Okay. Stop scanning it and go to the URL there. Man, that's really unfortunate. I even tested it. Dang. I'll take a picture of this. But yeah, if you actually go ahead and take the URL there, that'll go to the demo. And when I upload the slides again, I'll make sure it has the correct QR code. But thank you, everyone. That's the talk there. So if you folks have any questions, feel free to ask. And this QR code, it's definitely guaranteed to work. And so if you actually scan this QR code here, it'll drop you into our public chat channel on Matrix. So one thing, maybe if you keep track of Ubuntu and various happenings there. Recently, the community adopted Matrix as the official chat platform. So maybe say if you don't enjoy using IRC per much, if you scan that QR code, it'll give you an invite to join the public room and actually ask questions if you say go through the demo about using Sunbeam. So yeah.